Okay, question 7. So this is our long answer question, or at least one of the long answer questions. So the first 6 marker, the 6 mark questions here are ones that students tend to run away from exams. They get scared by them because they feel as though there's they're hard questions. But the reality is, it's quite easy to pick up a couple of marks on a 6 marker. The first couple of marks are dead straightforward. But I'll show you how to answer this well. The best advice I can give you on a 6 mark question, or what we call a long answer question, anything 4 marks and above, is to have a plan. It doesn't take long just to jot down a few ideas, because what happens is, as we write, we tend to forget what we're actually being asked to do, and people just write and write and write, and then by the time they finish the question, they don't want to read everything they've written and just move on. And the first couple of sentences probably started to address the question, and then I tend to find that the longer the answer, it just waffles on and doesn't actually meet the mark scheme. So we want to plan and always keep coming back to the question, so that you're checking, am I actually answering the question I'm being asked? So the information in the box is about the properties of solids and gases. Solids have a fixed shape and are difficult to compress. Gases will spread to fill out the container and are easy to compress. Use your knowledge of kinetic theory. Kinetic theory is, particle model. So a particle model. So we can think about that already. So a solid, in terms of the particle model, here's our solid. We know that they look like, that's not a regular solid. Bigger particles are always the best way to start. So, because in a solid, all the particles are touching, they're arranged in this regular formation like that. So that's your solid. And then we're not asked about liquids. So don't start talking about liquids. We're asked about solids and gases. And the gases, particles are the same size, but they're spread out and they're not touching at all. So they spread out to fill their container. So we said we have to explain why they have a fixed shape and why solids are difficult to compress, and we have to explain why gases fill their container and why they are easy to compress. And we have to talk about the spacing of the particles, the movement of the particles, and the forces between the particles. So I'm going to create a bit of a grid just to make sure that I can come back to it and then I've actually done those things. So I have to talk about solids, and I have to talk about gas. And I have to mention the spacing of the particles. I have to mention the movement. And I have to mention the forces. So what I'm going to do is, as I'm going through, I'm going to tick off this to make sure I've done those things. And I have to link those things to the shape. So let's start with the spacing in the solid and the gas. It's the dead straightforward one. So we'll start with, in a solid, the particles are in a regular pattern and close together. No, they're actually touching. Ooh. So you can see that from my diagram here. So I've mentioned the spacing. Now, I need to link that to one of these properties. So is that to do with the fixed shape or why they're difficult to compress? Well, it's actually to do with both, isn't it? So in a solid, the particles are in a regular pattern and are close together. They are hard to compress as there is no space for the particles to move into when squashed. Yep. So get the idea of this solid here, this fixed shape. If you squash it, well, where's it going to go? There's nowhere for a particle to fit into. They are all touching already, so you can't compress them. That's why. So let's talk about the the movement. In a solid, the particles vibrate in a fixed position. Can we use that to explain why they have a fixed shape? No, not really. And are difficult to compress? Again, no, not really. But we have talked about the movement, so we'll put that on there. The last thing is the forces. The forces. Now I'm going to move on to the next page because I've got extra space. The forces between particles in a solid are strong. So they've got strong forces. So if we think about this solid here, so there are strong forces holding each of them next to each other. And that's why they have a fixed shape. And it's because every particle is really strongly attracted to the next one. So the force between each particle of solid are strong, which gives them a fixed shape. Okay, so we have talked about the forces, and we have said that they have a fixed shape, and we've explained why they're different from compressed. So we've done enough on all of the solid stuff. We've mentioned each of the properties, and we've used that to explain the two, the fixed shape and difficult to compress. So now we need to start talking about the spacing, movement of forces in gases, and use that to explain why they'll spread out to fill a container and why they're easy to compress. So let's just start writing. So spacing. So remember, a gas, here was our gas. The particles are spread out like that in a gas. So in a gas, the particles are arranged randomly and spread far apart from each other. Okay, so we have mentioned the spacing. Can we use that to explain why they will spread out? Yeah, actually we can, because they will spread out to the container. And can we explain why they're easy to compress? Well, yes, actually we can, because again, they can move into these spaces. So let's use that to explain why they're easy to compress. So in a gas, the particles are arranged randomly and are spread far apart. They can be compressed easily as there is lots of space for the particles to move into when squashed. Yeah, so if you put a force on here, on this particle, well, that particle can move because there's lots of space. If you put a force on that particle can move. So you could shrink this whole box down to that size and the particles could move. In fact, you could shrink it even smaller because we could move those particles into a really small space like that, couldn't we? So the particles can move. So that's why they're easy to compress. So we go back and we can say, well, we've done that one. We talked about that one. So let's talk about the movement. So in a gas, the particles move randomly in all directions at high speed. They're moving fast because they're melted and they're in a gaseous state, so they're moving quickly around. Okay, so we have talked about the movement, and we'll use the forces to explain why they spread out. So the forces between particles in a gas are 0. So the particles are free to move apart and fill their container. All right, like in a solid, they had a fixed shape, didn't they? In the solid, we saw here, in a solid, we've got this fixed shape. We've got strong forces. In the gas, there's no forces holding any of the particles together, so they will just spread out and they will fill their container. The forces between particles in the gas are 0, so the particles are free to move and spread apart and fill their container. So we have now talked about our forces. So we've done every single thing we need to do there, and we have now explained why they fill the container. So by referring back to our question constantly, it means that we stay on track with our long answers, and we make sure that we're going to hit that mark scheme, and we don't start going off and just talking about things that are closely linked to the ideas. That's the bit of advice I'll give you, is constantly go back, constantly keep reading your question, constantly keep relating your answer to what you've been asked to do, and nothing else. And if you start writing about something else, just cross it out, because it's not going to be related, and you could in fact actually say something that contradicts your answer. Okay. The last thing I would say is just read through your answer before you're happy and move on to the next question, and just make sure it makes sense.